Hello and welcome. In this video, I'm going to go through Additional Mathematics Form 5 textbook question for Chapter 6 Trigonometric Function Summative Exercise. My name is Terry. If you enjoy this video, kindly like, subscribe, and leave us a comment. Right, let's go straight to this. Okay, the first question, they asked us to find the range of angles for the following angles in radian. So you want to find the angle in radian. It's given in degree, you just convert to radian. So I guess most of you are familiar with angles in degree. It's just that in maths we have to learn about angles in radian. But you already have some background in your first chapter, chapter 1, circular measure. Yeah, we know that pi is 180 degrees. So in this case, 0 degree is still 0 radian, but 360 will be 2 pi radian. So answer for A will be x between 0 and 2 pi. Okay, pretty straightforward. Now, how about negative 180 for B? We know 180 is pi, negative 180 will be negative pi. Now, if you take 180, you divide by 2, you get 90. So for angle in radian, 180 is when you convert to radian is pi, so 90 will be pi over 2. Okay, simple as well. How about part C, 270? Okay, if you find this difficult to convert, you don't remember, so this is what I'll do. I know that 180 degree is pi radian, so 1 degree is pi over 180 radian. 270 degree is 270 times pi over 180. This will be 3 pi over 2. Yeah, so or we can think 1.5 pi radian. So this is 3 over 2 pi for 270. But for 720, we know 180 is pi. I think we can just times 4, right? Yeah, 720 is just 180 times 4. But if you cannot remember, we'll just take 720 times pi over 180, cancel them, you get 4 pi radian. So this is 4 pi radian. Okay, I don't have to put a radian, it's understood that the question already says it's in radian. Alright, that is question number 1. Okay, moving on to question number 2. So now you want to write angle in radian given the type of angle. Now we know there's a few types: acute, obtuse. If you want to count right angle as well, is 1, right? And lastly, reflex angle. Now, acute angle is angle between 0 to 90. Now in degree, you are familiar with angle in degree, right? So if you want, I can write in degree, then I write in radian. So in degree is 0 to 90. In radian, we'll just change 90 to pi over 2. Yeah, you can write this in radian. Okay, how about obtuse? Now we know acute is quadrant 1, 0 to 90. Obtuse will be between 90 to 180. So in degree is 90 to 180. In radian, you divide by 2. 180 is pi, 90 is pi over 2. So there you go. It's between pi over 2 and pi radian. Okay, how about reflex? Now reflex is quadrant 3 and 4. It can be either quadrant 3, 180 to 270, or 270 to 360. That will be quadrant number 4. So here we have two bigger range, 180, 2 quadrant to consider, 360, 180 to 360. In radian, 180 is pi. In 360 is 2 pi radian. Okay, I think this is still quite straightforward, right? Okay, move on to question number 3. State all the angles between 0 and 360. Yeah, given the trigonometric ratio. So these are given in degree. You're supposed to find angle in degree. So part A, sine theta is 0.66 and negative 0.66. So I'll just write this as plus minus 0.66. Okay, so the first thing is you need to use your calculator. So I hope you already know how to find reference angle. In fact, you've learned this in your mod maths, normal maths. Okay, and this is a summative practice or summative exercise. So I already assume that you already have some basic, right, in the previous part of the chapter that you learn all this. Shift sine 0.66, you will get your reference angle 41.30. Now, if you want me to illustrate, you can actually use a simple unit circle and we draw a unit circle like this. I remember a unit circle has a radius of 1, right? It looks like this, and 0, -1. So if you have a sine value of 0.66 plus minus, sine is represented by your y coordinate. So that means if this is 1, 0.66 around here, your reference angle is here in quadrant number 1, or it can be in quadrant number 2, right? Okay, so maybe I should not write this as theta. Reference angle, you can use REF, theta REF, or you can just say alpha, right? So, and we want to find the general angle. So general angle is the angle measured from the positive x-axis. So if it's in quadrant 1, we can say we measure from here to here, here to here, quadrant 1. Your theta is the same as your reference angle, 41.30. And if it's in quadrant 2, we have to take 180 minus 41.30, as I am finding the angle from here to here. This is your reference angle, 41.30. This is your general angle. We need to do 180 minus, as total angle for straight line is 180, right? So 180 minus 41.30 gives us the general angle. Okay, but that is only quadrant 1 and 2 for positive sine. If I want negative 0.66, then I will consider here quadrant 3, quadrant 4, right? This is negative 0.66. Yeah, sine, remember, is your y coordinate. Look at your y coordinate. If your reference angle is here, again, alpha is 41.33. Over here, alpha 41.33. We have to take 180 plus for quadrant 3, 41.30, and last one, 360 minus 41.30. And with that, I will have 4 answers. First one, 41.30. Second one will be 138.70. Third, 221.30. Lastly, 318.70. Now, one thing, the quick way to test this is you take this value and sub inside your sine here, your theta here, and calculate. You should get a number close to 0.66. Not exactly 0.66, because this value, the reference angle here, we have already rounded it off. So sometimes you won't get exactly the same, but you get a value that is close to it. Okay. So now that I've explained briefly about using unit circle to find your general angle from your reference angle. So for B and C, I'm not going to do that. We're just going to do straight away. We know secant is now plus minus 2.2727. Yeah, 2.2727. And secant is 1 over cos. So what we can do is we can invert left and right, 2.2727. Now, you don't really need to type this in your calculator and write this answer down. You can actually do it one shot, but if you want, it looks like this, 4400, such a nice number. And to find theta, we shift cos. Now, remember, when you shift cos, shift sine, drop the negative, because what we want is the reference angle. Reference angle, or you can call this as alpha, is 63.90. And again, similar to sine earlier, here we are finding all 4 possible angles. Now, when you use what do you call that, the unit circle, if you use a unit circle, now we know cos is positive in quadrant 1 and 4. But because of the plus minus, we have to consider quadrant 3 and quadrant 2 and 3. Yeah? So here your theta will be the first answer, 63.90, quadrant 1. Quadrant 2 is 180 minus 63.90. Quadrant 3 is 180 plus 63.90. And quadrant 4 is 360 minus 63.90. That will give us first answer 63.90, second answer 116.10, third answer 243.90, last answer 296.10. Okay, looks like I don't have enough space for C, so I'm going to move up and do C right down here. Okay, so for part C, it is cotangent. Cotangent theta is plus minus 1.136. Okay, again, cotangent is 1 over tangent. I hope you know your reciprocal function. Cosecant is 1 over sine, right? Secant is 1 over cos, and cotangent is 1 over tangent. So here, I will just invert the left and invert the right. Just put a plus minus 1.136, and then you can use a calculator and write this down. Actually, it's not important. You can just do it one shot. You don't have to write down this answer. Here I use one more decimal point, use 5 decimal point. Instead of usual 4, I use reference angle, shift tangent. I use a calculator, you get 41.30. Now, similar to sine and cos, because of the plus minus, right, you have to consider all 4. Normally, tangent is positive in quadrant and 1 and quadrant 3. So your reference angle is 41.36. You can write it down. But because of the plus minus, I have to consider quadrant 2 and quadrant 4, the negative quadrant as well. So you get 41.36, the first answer. Second answer, 180 minus 41.36. Third answer, 180 plus 41.36. Last one, 360 minus 41.36. So you got 41.36 first answer, 138.64 second answer, 221.36 third answer, and the last one, 318.64. Okay, yeah, this is, I would say, still quite easy, yeah? Pretty basic. Okay, now we still have a lot of questions coming up. Question number 3 done. Question number 4. Without using a calculator, find the value of each of the following. Okay, now when we say without using calculator, normally we're referring to using the special angle. The special angle will be 30, 45, and 60. These are the 3 special angles that we normally use. Triangle. You can use triangle. You can use finger rater. I call it finger rater. Special. Use finger to actually work it out, the values. Or we can use the 570 ms calculator, either the class with the silver one or the black and white one. These 2 calculators can actually find angle directly. Yeah. So although we say without using calculator, but you still need to show, or should I say, express this in terms of sine, cos, tangent of 30, 45, and 60. Then you use your calculator. Okay, let me show you. So the first one, I want to find sine negative 120. Okay, so I'm going to do a sketch. Where is negative 120? Now we know for positive angle, we go clockwise, anti-clockwise direction. But this is negative angle, so we should go anti-clockwise, right? So as I go negative 120 here. Now, your reference angle is measured. Remember, characteristic of reference angle, for those who probably haven't heard this before. Reference angle has 3 characteristics. Number 1 is always respect to x-axis. Number 2 is always an acute angle. And number 3, it is always positive. So always remember that. General angle is the angle that you measure from positive x-axis. Reference angle has these 3 characteristics. You move down towards the x-axis, you measure this angle, and we know this is 60, right? It's acute angle, can never get reference angle that is more than 90, all right? And it's always positive. So number 1, we express the sine of the angle in general angle in terms of your reference angle. In this case, sine 60. And number 2, you have to apply the ASTC. Yeah? All science teacher crazy. Only science teacher, not maths teacher, right? So in quadrant number 3, sine is negative. Only tangent is positive. So you want to put a negative here, all right, and write this as negative sec 3 over 2. Okay. Now, tangent 480. Okay, how do you do 480? Okay, now we're going to go beyond 360. You go 0, 90, 180, 270, 360. Okay, right? Okay, by the way, before I forget, so I'm really assuming that you know how to find sec 3 over 2 here from calculator. Now, let me just clarify one thing. If you do not have the 570 EX, the class width, or the silver calculator, right? So EX plus, so you can use even the normal 570 MS calculator, the gray one. You can also find out directly how. You just have to remember sine 30. So all these are extra stuff that you may find this helpful, because if you type in your calculator sine 30, you get 0.5 or 1 over 2, right? I know this. I can draw a triangle out. I know this is 30. I know sine is opposite. This is my opposite. Over hypotenuse is opposite over hypo. My hypo is 2. My adjacent will be 2 square minus 1 square root, which is square root 3. Well, once I got this, I can find everything else. Why? Because this is 60. How do I get 60? 180 minus 90 minus 30. This is 60. Now with that, I can just read directly from here. Okay, for example, I want to find sine 60. I just read My opposite is sec 3. My hypotenuse is 2. There you go. I got sec 3 over 2. Yeah. But if you have silver calculator, the grey calculator, the 570 ES class with the black and white, just type in sine 60. Yeah, you get sec 3 over 2 right away. Okay. All right. Next, haven't finished this stuff. 480. Where is it? 0, 90, 180, 270, 360 here. Beyond 360, after 360, you plus 90, you get 450. Right. 450. 480 is more than 450, so you go more than that. It's around here. 480. Oh, my line is not straight. Now this will be 540, right? After 450, you plus 90, you get 540. So you can see it's in quadrant number 2, right? And again, quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's how you read a quadrant. Your reference angle is still 60. If you take 540, you minus 480, the difference is still 60. So this tangent 480, number 1, I express this angle in general angle to reference angle tangent 60. I know that it's in quadrant 2. Quadrant 2 tangent is negative, so this is negative tangent 60. Okay, we can go back to our triangle. Okay, what's my tangent 60? Look at this. Tangent 60 opposite is sec 3, adjacent is 1, so it's negative sec 3 over 1, or just negative sec 3. Okay, lastly, secant 750. Okay, where is 750? So number 1, I'm going to go 0. This is 90, 180, 270, 360, 450, 540, 630, 720. After 720 is 810. Yeah, keep adding 90 to each. So you notice one cycle I end up at 360, not enough. I go to 2 second cycle, I end up at 720, still not enough. 750 is slightly more, 750. So we take 750 minus 720. The difference is 30. My reference angle will be 30. So here we have secant 750. Secant is 1 over cos, right? And we need to express this in terms of its reference angle, which is 30. Oops. Oh, this is a bit ugly. Let me fix this. Cos 30. And in quadrant 1, all 3, sine, cos, and tangent, they are still positive. So this will be 1 over sec 3 over 2. 2 over sec 3. Now I know some of you would type in the calculator, then you wonder, hey, how come my calculator give me answer as 2 sec 3 over 3? Oh, that's because the calculator will rationalize the denominator automatically for you. You know that in form 4 you've learned about sec, right? If you have 2 over sec 3 and you multiply top and bottom by sec 3 just to get rid of the sec in your denominator, that's why we call it rationalizing the denominator. So we want rational number, we don't want sec, okay? So you get 2 sec 3 over 3. But it's okay to leave it like this. If you want to change to this form, it's also okay. Alright, that's number 4. We haven't finished yet. We still got part D, E, and F. Okay, the difference is now the angles are in radian. Okay, you're familiar with degree, but this is in radian. Now, the first thing is cosecant. Okay, what do I do with this cosecant? Now, this is a bit unique because the angle is doesn't involve special angle. This is pi. So number 1, let me write this as 1 over sine 3 pi. So I know I can't be thinking 60, 45, or 30. Yeah, even in radian. So because this is pi in pi. So what you do is you can use a unit circle. Now we know unit circle looks like this, right? So this is 0. This is 1 pi. Now go 1 round. The second round is 2 pi. Yeah, I'm going like this, 2 pi. Then 3 pi would be right here. Correct. And this is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. So remember, in unit circle, sine is your y coordinate. Yeah. So for those again, for those who don't know about this, I can draw this for you. This is theta. Sine is your opposite. If I write xy, this is your y value. Your unit circle has a radius of 1, right? So this is your x value. So your sine theta is your y over 1, basically your y coordinates. So if you know your y coordinate, then you can find your sine value straight away. Now, here, when you go 1 round and a little bit more up to here, my y coordinate here is actually 0. So this is 1 over 0. Now I know it sounds a bit weird. It is a bit weird because 1 over 0 is what? Infinity. Yes, the answer is infinity. Yeah, no exact value is infinity. All right, let's move on. How about C, cotangent? Okay, number one, maybe I draw it out. I know this is negative angle. Okay, so we know 0 is here, negative pi over 2. Again, you need to get familiarized with angle in radian, right? So 1 pi radian is 180. Pi over 2 is 90. So this is negative 90, negative 180, negative 270, negative 360, and so on. Okay, now I don't know where to stop. So number one, you can think, let's just use your calculator or use your brain. 9 over 4, change to mixed number 2, 1 over 4 pi, right? Now if you have a negative, just put a negative in front. So what does that mean? That means we start from here, we go 1 pi, negative 1 pi, negative 2 pi, and negative 2, 1 over 4. Now 1 over 4 is less than half, so it does not cross over to here. Now if you want to add, this will be negative 2.5, or you can say negative 5 over 2 pi, right? So it's actually somewhere here in quadrant number 4, and we move down towards the x-axis. You take this 2, 1 over 4 pi, you minus 2 pi, the difference is 1 over 4 pi. Now again, you need to get familiarized with angle in radian. We know pi over 2 is 90, pi over 4 is 45. This is your special angle. So cotangent, number one, as we know, is 1 over tangent. There is a negative 9 over 4 pi. Number two, the negative 9 over 4 pi is angle in general angle. So you got to express in terms of your special angle. So you need to put a pi over 4, and here, because of ASTC, quadrant 4, only cos is positive, tangent is negative. So you need to put a negative in front, right? And we know negative tangent 45 is 1. You put a negative in front, so it's negative 1. Okay, one more thing. I forgot to tell you this, okay? In case you want to know, just now I went through with you sine 30. Sine 30 equals 1. Now, how about 45 degree? If you want to find out 45 degree, it's the same. You know from your calculator, the other two calculators, silver and the black and white calculator, you can find directly. For the gray calculator, 570 ms, yeah, you can't. You can only do this. Tangent 45 equals 1. This one you can type in calculator. This calculator, the gray calculator, can give us this answer. The gray calculator can give us sine 30 equals half, tangent 45 equals 1. The rest are all in decimal, not in set form. So you need to draw out a triangle, which is not difficult. I draw like this. We know tangent is opposite over adjacent, which is 1 over 1. So your another angle here is also 45. Why? 180 minus 90 minus 45. You get another 45. Now, if I take 1 square plus 1 square, I put a square root over, I get square root 2, right? So once I can find the hypotenuse, I can find all 3 sine cos tangent of 45. Yeah, sine 45 is 1 over sec 2, right? My opposite is 1, hypotenuse is sec 2. My cos 45 is adjacent 1, hypotenuse is sec 2. Yeah, you can find everything, right? But this is tangent 45. Yeah, tangent pi over 4 is the same as tangent 45. It is also 1. Okay. All right. I have very little space for part C. Okay, part F. Okay. Anyway, where's negative 8 over 3 pi? Now we know 8 over 3. We can think negative 8 over 3. Think negative 2 over 3 pi. So similar. The diagram is quite similar to part E. Yeah? Okay, this is E. Sorry for the fact that it's a bit messy or very messy. So where is negative 8 over 3 pi? This is 0, negative pi over 2, negative pi, negative 3 over 2 pi, negative 2 pi. Negative 2 over 3 is more than negative 2.5. This is 2.5. This is negative 3, right? So look at this. Let me use a color pen to highlight this for you. Is more than 2.5, but less than 3. Yeah, but it's negative, so we have to go clockwise direction, move down towards the x-axis, find the difference, take 3 minus 2 to 3, the difference is 1 over 3 pi. Yeah, so negative 2 to 3 is over here, you minus with negative 3 pi, the difference is 1 3. So what do? Cos negative 8 over 3 pi, we can express in terms of cos of its reference angle. My reference angle is 1 over 3 pi. Since it's in quadrant 3 is negative, only tangent is positive, so it's negative cos pi over 3, which is cos 60. If you cannot remember, read from the triangle. Cos 60 here is adjacent 1, hypotenuse 2, so it's 1 over 2. Go back. Answer is negative 1 over 2. Okay, we're done with question number 4. A long way to go. Let's move on to question number 5. Okay, this one you have to use brain. Now this question is very interesting, super interesting. Right, so we start off with sine A equals to 5 over 13 and sine B equals to 4 over 5. So they say find the value of sine cos A minus B tangent A plus B if A and B are acute angle. Okay, so for part A, no real issue, we draw a triangle. Okay, so I hope we know now if they say angle is acute, so we know you have to draw in this direction. Your opposite, sine is opposite over hypo. This is 5, hypotenuse 13, adjacent is 12. Okay, yep. How do I get 12? 13 square minus 5 square square root. Pythagoras, 12. Okay, how about B? Just draw a triangle. Sine B, opposite is 4, hypotenuse is 5, adjacent is 3. You know why? 5 square minus 4 square square root, you get 3. Okay, so the first thing is you need to know the formula for cos A minus B, right? Now, cos A minus B is given by cos A cos B plus sine A sine B. Yeah, I hope you know this. Cos cos, sine sine. If this is a minus, this is a plus. Okay, now next I'm going to sub in my cos value. If I read from here, cos A is adjacent, which is 12, over hypotenuse, which is 13. Cos B is adjacent, which is 3, hypotenuse, which is 5. Now sine A you can read directly from the top here. Yeah, 5 over 13 times 4 over 5. So this will be 36. Okay, I'm going to show you one by one, so it's easy for you to see later. This is 20 over 65. Answer 56 over 65. Okay, right. Now, how about second part? Because I'm finding 2, I'm finding cos A minus B and tangent A plus tangent B. Okay, tangent A plus tangent B is tangent A plus tangent B divided by 1 minus tangent A times tangent B. Okay, what is my tangent? Okay, you got to read from your triangle here. Tangent is adjacent 5 over opposite 5 over adjacent 12. So it's 5 over 12. Okay, let me write here 5 over 12. Tangent B, I read from here, adjacent is 3, opposite is 4, adjacent is 3, so it's 4 over 3. Yeah, I don't have a pointer tool, so that's the thing. If I have a pointer tool, it's easier for me to point out to you, so it's okay, I just highlight. So now the top part is for me, I will actually don't have to count one by one. Yeah, you can use a calculator. I would think this way: 5 times 3, 15, 15 plus 48, which is 63. Then the denominator, I'll take 12 times 3, 36. 36 times 1, 36. 36 minus 20 is 16. So I get 63 over 60. Now here I'll just leave it like this. Okay, so I don't want to write one by one. Okay, you can write one by one if you want. Okay, now let's look at B. Part B, A and B are now both obtuse angle. Okay, now at first I'm also tempted to redraw the triangle, but I'm thinking, hey, wait a minute, the figures are all the same. The only difference is now that my sine is positive, cos and tangent is negative. That's why I say this question is very interesting. when A and B are obtuse, right, your sine A is still more than 0, sine B is still more than 0, your cos A is less than 0, cos B is less than 0, tangent A less than 0, tangent B less than 0. Now, you don't have to write all these things. I just want to show you. Because of ASTC, if you redraw the triangle, you're going to get the same thing. So you don't have to. You just have to change the sign, either plus or minus, for all three sine, cos, tangent. So for the first part, cos A minus B, you see, my cos value here, look at this cos value here, just highlight the blue color. Okay, this cos value will change. It's going to be negative. My tangent value is going to change. They are going to be negative because AB are now obtuse. So what I'll do is I will just don't need to copy. I don't want to copy the formula. We know it's cos A cos B, right? So I change this to negative 12 over 13. I change this to negative 305. Sine A sine B remains the same, 5 over 13 and 4 over 5. Now you notice but negative times negative is going to give us positive. So this value here is still going to give us the same value as before, 36 over 65, because double negative times together is still positive. And you add the same value as earlier part, the 5 over 13 and 4 over 5. So your end result is going to remain the same, 56 over 65, right? It's not changing, it's the same. Okay, how about tangent? This is interesting because tangent is now negative. So what I do is, okay, again, I don't want to rewrite the formula. Just take note, before this I use a green color. Before this, these two are positive, right? Okay, because in quadrant 1, all the tangent values are all positive. Now I just change to negative, negative 5 over 12, negative 4 over 3. This is 1, all right? The formula is still minus, but this is negative 5 over 12, negative 4 over 3. So what happened is you're getting double negative, right? You're getting double negative. So the top is negative, bottom is negative. When you divide it, what happened? You're still going to get positive. You're still going to get, I mean, okay, let me say this again. Okay, the top is negative, bottom is still the same. Okay, look, maybe I write this down. Okay, it's best I write this down for you lah. This is 7 over 4. If I actually don't have to, but I just want to show you, 1 minus 5 over 12 times 4 over 3. This is 4 over 9. Now the difference is, this is now negative 7 over 4, but your denominator is still 4 over 9. Correct. So you will get negative 63 over 60. Isn't it so? Yeah, this is negative now, because you notice this value here, I should highlight the different color, is the same as this value here. Because of double negative, still positive, okay? Right, so, okay? Okay, let's look at C. C is very interesting. Cos A and cos B are negative. Yeah, wow. You think about it, cos is negative, not only one quadrant, no. Cos is negative in quadrant 2 and quadrant 3. So here we have two possibilities. The answer has two parts. The first case will be quadrant 2, which is what I've done here. Yeah, this is quadrant 2, isn't it? Yeah, A is quadrant 1. So I figure they may have two possible answers. So okay, so I'm going to move this up. Okay, now we need to test out with quadrant 3. Quadrant 3. Now in quadrant 3, A and B, okay, I cannot say A and B obtuse because it's reflex. Reflex can be 3 or 4. So don't care about A, B, just say sine A is now negative. Quadrant 3 sine A is negative. Sine B also negative. Cos A is still negative. Cos B is still negative. Tangent A is positive. Tangent B is also positive. So it's actually not going to affect your answer for cos A minus B. See, your cos A minus B, your cos is still negative, so you can just copy back this one, the blue one I highlighted earlier. Cos is still negative, right? Okay, it's not going to be affected, right? So okay, I'm going to put negative. Okay, but my sign is still negative also. Okay, previously my sign is positive. See, previously my sign is positive, now my sign is negative. Just change to negative to negative 5 over 13 and negative 4 over 5. But again, it's not going to affect the answer because double negative is positive, double negative is positive. I still get 56 over 65. Right. Okay. Now, how about tangent? Okay, now tangent is positive. Previously, tangent is negative. So you just have to compare this with the first one. See, my first one, tangent is all positive. Look at this. Tangent all positive. So I just sub in the positive tangent. Sorry, I don't have space, so I just show you this. 5 over 12, 4 over 3, 1 minus 5 over 12, 4 over 3. So is, wait, tangent is positive. I get positive value. Yeah. This will be 63 over 16. Okay. Right. So now notice this answer, yeah, I forgot to check the answer. Yeah, that your cos, right? Cos A and B are negative. Your cos A minus B remains the same, but your, yeah, it's still positive, right? 56 over 65. But your tangent, yeah, can be positive, can be negative. Yeah, your tangent can be positive. Here, the first one I got negative if it's in quadrant 2, right? Yeah, but if it's in quadrant 3, then it will be both. It will be positive. Yeah, it will be the same. So that's why this one is a bit tricky because you have two answers to it, right? The first one is, okay, because they say cos is negative, right? Now read this. Cos A and cos B, they are negative. That means it can be quadrant 2, can be quadrant 3, right? So yeah, so we don't know, right? So that's the problem with this question. And yeah, so you got two possible answers. And another thing is that I haven't even matched up quadrant 2 match up with quadrant 3. Yeah? So you can see, I guess they have to, yeah, clarify this. Cos A and cos B are negative, right? You see again. So this cos is negative in quadrant 2 and 3, right? So for quadrant 2, this is true, this is true. So quadrant 3, this is true. So A is not affected, the first part. But the second one, this tangent, if both are in quadrant 2, then both are negative. If both are in quadrant 3, right, then it is positive. Okay, so I shouldn't go further than this because, yeah, there are two possibilities, right? So yeah, so you can say that your answer can be this, depending on your quadrant. Okay, so let's move on to question number 6. All right, now this is easier. Diagram on the right shows 3 graphs, y equals a cos bx for x between 0 and 2 pi. Copy and complete. Okay, so we know that there are 3 equations here. The first equation is the red one, you can see, is y equals to cos x. All right, the second one is y equals to the like yellow color one, 2 complete cycle. Yeah, the first one is a simple cos 1 cycle, second one is 2 cycle, as you can see. The third one is only half of a complete cycle, so we write y equals cos half x. So your number of cycles for the first one is 1, second one is 2, third one is just half. Okay, how about the period? Okay, the first one, the period is period, as we know, for cos is given by 360 divided by 360 or 2 pi divided by b. Now your b is 1, so the first one, b is 1, 2 pi divided by 1 is just 2 pi. Second one, 2 pi divided by 2, which is just pi. Third one, 2 pi divided by half is 4 pi. Okay, should I explain 2 pi divided by 1 for the first one? the period is just 2 pi. For the second one, period is 2 pi divided by 2, which is pi. For the third one is 2 pi divided by half, which is 4 pi. Okay, what is your class interval? Now, class interval refers to, in this case, one quadrant. So for one quadrant, in the first case, right, you can see from the yellow, for the pink color or red color line, you can see is pi over 2. Yeah, you have one cycle has 4 quadrant if you like. So this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. So you achieve one quadrant, or you complete one quadrant in pi over 2. But for cos 2x, right, as we know, the number of complete cycle is double. So you achieve, or you reach this at pi over 4. Is half of the previous one. Now the third one, you only do half of a complete cycle for 2 pi, and one quadrant is therefore just pi. Okay, moving on to question number 7. State the period of the graph. Okay, now the graph is y equals to sine 2x. Okay, so now your period is now 2 pi divided by 2, which is just pi. Yeah, no problem. Okay, B, state the amplitude of the graph. Okay, for this graph, the amplitude for 1 plus 2 cos 3x, your amplitude is just 2. Okay, easy. Okay, next, let's look at, we need to find the maximum minimum as well. Sorry, maximum minimum value y. Now we know cos has a maximum of 1, minimum of -1. Yeah, so should I say cos x? You can write like this. I can write starting from here. We know cos 3x. It can be cos 2x, cos 3x, because this is for cos, it just has a maximum, minimum 1 and -1. Right? So we just times everybody by 2. So this is just 2 and -2. Then you plus everybody by 1 here. So I plus 1. This is times 2. This is plus 1. This is -1. 1 plus 2 cos 3x. This will be 3. So my minimum is -1. My maximum is positive 3. Okay. Next, on the same axis, we want to sketch both graph for 0 to pi. Okay, this is a bit long. The graph is, we need to draw sine 2x and 1 plus 2 cos 3x. Okay, so now maybe I explain briefly. Now we know normal sine, right? The normal sine graph looks like this. The moment it has a maximum 1, minimum -1. The moment you put sine 2x, we have to do 2 cycle. But this is from 0 to 2 pi. What I want to do is I want to draw from 0 to pi, only stop at pi. So I do not want the rest of this. I just want 0 to pi, right? As for the cos, a normal cos graph is cos x. It looks like this, from 0, maximum 1, minimum -1, 0 to pi. But here I'm drawing 2 cos x. Okay, that means I have to draw up, down like this, maximum 2, minimum -2. What if I have 2 cos 3x? Okay, 2 cos 3x means we have to draw 3 cycle. Yeah, but again, we only want to draw up to pi. So here you got to cut it off at pi. Now 2 pi is here. 2 pi has 3 cycle. 1 cycle has 4 quadrant. 1 cycle has 4 quadrant. Okay, so 3 cycle should be 12 quadrant. So if I draw up to 180 or pi, so I need to halve this. So I have to draw 6 quadrant. Yeah, I'm drawing 1.5 cycle up to 6 quadrants. So now, then lastly I have to plus 1. Okay, the plus 1 I handle that later. We'll shift up by 1. So let me just draw like this. Okay, and I know my maximum for cos will be 3, right? Minimum -1, so I just put 3, 2, 1, 0, -1. Draw a horizontal line. I need, for sine, I need 4 segment. Yeah, because I'm only drawing half of a complete cycle. For cos, I need 6 segment. But it's a bit hard to see because I'm drawing both graph within the same axis. Okay, but I know my cos x have to shift up by 1, guys. This is 2 cos 3x. Okay, it looks like this. I will shift up by 1. But when you have a +1, I shift up by 1. I have to start here. Okay, so I want to subdivide this into 6 parts. So it's 1, put here, another point here, another point here. Can you see some subdivision? It's not very clear, but yeah, it's good enough for us to draw. Okay, sine graph is easier because we only have to draw starting point here, 1, 2, 3, 4, 5. I'm drawing sine 2x from 0 to pi. This is pi, this pi over 2, this will be pi over 4, this will be 3 pi over 4. Okay, so it goes up, down, down, and up. Okay, this part is very ugly. I change it. Okay, but ugliness is not a crime. Okay, not too bad. Okay, now how about cos? Okay, for cos graph, right? Maybe I have to move this down to show you this. When you do 2 pi, you remember you're drawing 3 cos 3x, so you must subdivide into 12 parts, right? So, but if you only draw pi, you must subdivide into 6 parts. But it's the same. 2 pi divided by 12 is still pi over 6. So this is pi over 6 here. This part here, if you take pi over 6 times 2, you get pi over 3, right? Then you take pi over 6 times 3, you get pi over 2, which is exactly the same as here. And then you times 4, you should get 2 over 3 pi. Pi over 6 times 5, you get 5 pi over 6. So this is how I subdivide everything. Yeah, if you cannot quite understand pi, right, you can think 180, you divide by 6, 30. 30 is pi over 6. Yeah, another way of thinking, right? So once I subdivided everything, okay, now I draw my cos graph. So I'm going to use a different color pen, easier to see. Use a blue pen. Okay, so I know this is my graph. I'm going to shift up by 1. So amplitude is 2. I know my maximum is 3. It goes down here. It goes down. Minimum is at -1. Right, a bit too low. Here. Comes back up. Goes back to 3. Comes back down. And down here. So it goes 1. Okay, sorry. This line is a bit ugly. One more time. 1, 2, 3, 4. Okay, you have to draw 1, 2. Okay, not too bad looking. Yeah. Okay. Now, with a bit of practice, I think you should be able to draw quite a nice looking graph. But that, yeah, it's not easy initially, right? With practice, you should be okay. Alright, so I've done the cos graph and the sine graph. So y equals to sine 2x. Okay, next. State the number of solution. Part D, I'll do it here. Number of solution to this equation. Now, you're given sine 2x minus 2 cos 3x minus 1 equals 0. Remember, the number of solution to an equation is number of intersection between these two graphs. I just have to rearrange it, bring everything to the right. I can see that this is my first graph, this is my second graph, right? So both of them share the same y value. In fact, they will have the same x value. That means you are finding the point intersection. They have the same value here. Maybe I highlight for you 1, 2, and 3, right? The same point of intersection. Oops, sorry, where were we? Now, so if this is your point intersection, there are 3 of them. So my number of solution, we're supposed to state the number of solution. The number of solution will be just 3. Okay. All right, that is for number 7. Let's move on to number 8. Okay, given a triangle ABC, show that sine A minus B times sine C is the same as sine square A minus sine square B. Yeah, if you have triangle ABC right now, one we know, we know that from a triangle like this ABC. All right, one thing about triangle is that sum of interior angle is always 180. Now, if you look at this formula, the first part, your left hand side has A, B, and C, all 3. But your right hand side only has A and B. So we need to get rid of C. To get rid of C, I'll take 180 minus A plus B, right? So before I sub in, I'm thinking sine C is the same as sine 180 minus A plus B, right? Now, you will learn that sine 180 minus theta is the same as sine theta, yeah? Okay, so in this case, and it's positive, so we can write this as sine A plus B, isn't it? Sine C is basically, in this case, the same as sine A plus B for a triangle. Okay, next, to show this, I think we can start off with left hand side. I'm going to write sine A minus B, and sine C I'm going to replace with A plus B, sine A plus B, yeah? So this will be, if you use the addition formula, it looks like this: sine A cos B plus, okay, sorry, sine is minus, cos A sine B. And here I need to multiply with sine A cos B minus, is a plus also, cos A sine B, sine cos, cosine. Right. Okay, the next thing is let's expand. Okay, I know this is a bit troublesome. I'm going to do 1. Okay, can't see. Okay, it's a bit hard to see. Okay, 1, 2, 3, and 4. You can multiply 4 times. Okay, so the first one, sine A times sine A is sine square A, right? Cos A times, because you're actually taking sine A cos B times sine A cos B. So it's sine square A cos square B. Okay, then the second one, sine A cos B times cos A sine B. Now this is a unique one because you have all 4. You have sine A cos A, sine B cos B. I just arrange it. In order: sine B cos B. Okay, then we take cos A sine A, sine B cos B. Again, you have all 4: sine A cos A, sine B cos B, and finally cos A times cos A cos square A, sine B times sine B sine square B. And you notice that these two are actually the same. Look at this. Look at this. Oh, they're actually the same. So we can just strike them off. Whoops, cut them off, right? Okay, now I'm left with sine square A cos square B minus cos square A sine square B. Alright, and from here, we're still not done because you look at the final answer. It's only sine, no cos, right? Now we know that cos square plus sine square is 1, right? Or should I say cos? Okay, I'll just write cos square A. Actually, first one we have to put B. So we make cos square as a subject is 1 minus sine square. Yeah. So this, okay, perhaps I should just use theta, right? Yeah, I use A. So hope you're not confused. This is just general. Shouldn't use A. I just use theta. So this is theta, 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 right? So my cos square B is 1 minus sine square B, whereas my cos square A is 1 minus sine square A. Okay, it looks very weird. Wait. Yeah, a bit weird, but it's okay. Right. So now let us just expand. This will be sine square A minus sine square A sine square B minus sine square B plus minus plus sine square A sine square B. Alright, again you can see that these two are the same. Oops, I like to use a different color. The same, right? But they're minus, right? So cut 1 plus 1 minus, can get rid of them, and you're now left with sine square A minus sine square B. Bingo. Right hand side. Okay, it's very long. Let's move on. Question number 9, another proving question. Okay, so I look at this, it's like, wow, so many tangent A and plus 60. So I think we can actually simplify first before I want to sub in, right? So I would say tangent A minus 60, right? When you expand is tangent A minus tangent 60. Okay, sorry, I haven't finished yet. Divide by 1 plus tangent A tangent 60. Okay, I'm gonna let tangent A be T, right? I like to use T. Yeah, normally we use tangent A, we use T. Higher level maths we use T. We don't write the tangent too many times. So this is T, and tangent 60 will be sec3. I hope you know we can get this from the special angle. So this is T times sec3, which is sec3t. Now, how about tangent A plus 60? It's the same. Just change the sign. Tangent A plus tangent 60, 1 minus tangent A tangent 60, T plus sec3, 1 minus sec3t. Now notice they're exactly opposite. A and B, the first one, tangent A minus 60, this one. You see the sign is minus plus, this one is plus minus, the other way round. Okay, now I'm going to sub inside. Okay, this is tangent A. Can you see that? So I start with left hand side. My tangent A, I'm going to replace with T. My tangent A minus 60 is T minus sec3 over 1 plus sec3t. Okay, my tangent A over here, there's a T here. This is plus, right? So T plus sec3, I'm going to use the result from here. Divide 1 minus sec3t. And the last one is these two times together. So I'm going to take T minus sec3, 1 plus sec3t, multiply with T plus sec3 over 1 minus sec3t. Wow, this is very long. But you notice that this is actually a form of fraction that we can actually combine the denominator. See, my denominator on this side here, yeah, it's quite clear. 1 plus sec3, 1 minus sec3. But this, I'm short of something. I'm short of 1 minus sec3. As for this next one, I'm short of 1 plus sec3. So basically, I need to combine the fractions. So here the first term, I'm just going to multiply top and bottom with 1 minus sec3t. For the second one, t plus sec3, I'm going to multiply with 1 plus sec3t. These two we can put together. Okay, I'm just going to copy. I don't want to expand first. Let me show you step by step. And my whole denominator is 1 plus sec3t. Oops. And 1 minus sec3t. Okay, let's expand the first one. Okay, this expansion is very long. T minus sec3t square minus sec3 plus sec3 times sec3 is 3t. Second one is t plus sec3t square plus sec3 plus 3t. The last one is easy. This is a minus b, a plus b. When you expand, is a square minus b square. So it's just 3. My denominator also I can expand is 1 minus 3t square. Okay, let's expand and simplify. Now, you notice this t and 3t I add up. You get 4t. As I times the t outside, I get 4t square. Okay? And this t, maybe I use red color, easier to see. I times in 1 by 1. Okay? So this will give us minus sec3t cubed minus sec3t. Okay, same here. These first two, I'm going to add this and this. I get 4t and as I times with t outside, I get 4t squared, and then this one I times 1 times 2, so I will get plus 3 3t cubed, right, and then plus 3t plus t squared minus 3 over 1 minus 3t squared. Okay, now look for things we can cancel. Which one can cancel? Okay, first 4t squared can't cancel. I can cancel these two though, right? Sub 3, negative sub 3t cubed and sub 3t cubed. I can cancel minus sub 3t, minus sub 3t. So then the rest, right, just add them up. Okay, this one, 1, 2, 3. Plus together, what do you get? You get 9, right? So this will be, okay, I need to move this up a little bit. Okay, this will be 9 t squared, and I still have minus 3 left. The last part here. Then you divide by 1 minus 3t squared. Okay, see, the final answer should be negative 3. Question say, show that it's negative 3. So we need to factorize. So I move this up. We can factorize negative. We take out negative 3. This will be, if I take out negative 3 and 9, divide negative 3 is just negative 3. But still have a t squared at the back. Negative 3 divided negative 3 is just 1. I just put in front. 1 minus 3t squared. When you cancel, you get negative 3. And this is the same as your right hand side. Wow, this is very, very long. Okay, but you notice if you use substitution, you let it be t, so the whole thing becomes much easier to write. Otherwise, you write a lot, tangent A, tangent 60. Yeah, a lot of things to write. So just let it be t. Yeah, the whole thing will be easier. Okay, can. So I move on to the next question, right? Question number 10. Okay, so this is a bit easier. Now, given that A is cos inverse 3 over sec 10, B is sine inverse 1 over sec 5, A and B are both acute angle, show that A plus B is pi over 4. Okay, number one, we can write this in the form of cos A equals 3 over sec 10. And sine B, okay, yeah, sine B is 1 over sec 5. Now, because they are both acute angles, so we can draw cos is adjacent over hypotenuse. Now, to find our opposite, basically we can just take 10 square root 10 square minus 3 square, put the square root over 10 minus 9 is 1, square root 1, this is still 1. Okay, for the second one, sine B, I know sine is opposite over hypotenuse. To find your adjacent, square root 5, I square it, I minus 1 square, square root, I guess square root 4, square root 4 is 2. Okay, I got this triangle ready. Now next, I want to find A plus B, right? So here we have three options. You can use sine A plus B, cos A plus B, even tangent A plus B. All three can work, but I think I just use sine. Sine A plus B, we know the formula goes like this, sine A cos B plus cos A sine B. Okay, look at sine A. Sine A is opposite 1, hypotenuse square root 10. Cos B is adjacent to hypotenuse square root 5. Cos A is adjacent 3, hypotenuse square root 10. Sine B is opposite 1, hypotenuse square root 5. So you put it together, it's 2 plus 3, which is 5 over sec 50, right? Now we know sec 50 is 25 times 2. We can square root 25. You're supposed to show that it's pi over 4. So 25 is 5, 5 sec 2, cancel 1 over sec 2. Now from here, you can sine inverse it, right? Sine inverse. Okay, let me just continue here so you can see the question. A plus B is sine inverse 1 over sec 2. This will be, if you use your calculator, pi over 4. Okay, that's number 10. Let's move on to number 11. Okay, now diagram shows the graph of y equals sine 2x plus sine x. from x between 0 to 2 pi. Okay, find the x-intercept. Okay, now the thing is, the first time I look at it, I tried to read from the graph, but then I figured that you can't get the exact value. So we have to solve this. We know at x-axis, y equals to 0. So you want to let your y here be 0. Now, I hope you remember your double angle formula for sine 2x. Sine 2a is 2 sine a cos a. In this case, 2 sine x cos x. Okay, now you want to take out your sine x, you're left with 2 cos x plus 1 equals 0. Alright, and then your sine x is either 0 or your cos x is negative 1 over 2. Alright, now from here, we can find sine equals 0 using a graph or using a special unit circle. Now we know if you use a graph, right, a quick normal sine graph, there are 3 answers. So your x is either 0. Since this is in radian, I cannot use 180, use pi. Next answer 2 pi. For cos x, we use special, this is a special angle actually, pi over 3. Or you can use your calculator, shift sine, shift cos, you get 60. In radian is pi over 3. Because this is negative, cos is negative quadrant 1 and quadrant 4. So my answer is pi over 3 and 2 pi minus 360 minus, this will give us 5 pi over 4. 4 pi over 3, sorry. 4 pi over 3. Wait, did I just make a mistake? This cos is negative. Oh my goodness, I put positive, sorry. Yeah, negative, yeah. Whew. I've been recording for more than an hour. More than about an hour, sorry. Lack of concentration. So this is pi minus pi over 3, pi plus pi over 3. This is 2 pi over 3, 4 pi over 3. So we got all 5 answers. There are 5. 1, 2, 3, 4, 5. Okay, now next, by using the same axis, sketch the graph y equals to cos 2x plus 1 and find the maximum, minimum. Okay, so I'm going to draw on the same axis. Okay, we know the basic cos x should look like this. Maximum 1, minimum negative 1, 0 to pi. Now, the moment you have cos 2x, so you need to draw 1 cycle, 2 cycle, double the cycle. This is up to 2 pi. Okay, and then number 3, you're going to shift up by 1. Now, maximum 1, minimum negative 1. When you shift up by 1, my maximum is going to be 2. Right? Okay, let me draw 2 cos 2x plus 1. Maximum going to be 2. Minimum is going to be 0. Yeah, here. So the graph should look like this. Okay, so let's draw. Now, I'd like to put a point first. 1, 2, 3, 4, 5. Then 1, 2, 3, 4. So it goes down, 2, 3, 4. 1, okay, a bit ugly. 2, 3, 4. Okay, right. Okay, next, we are not done yet for part B. They say sketch the graph, but we are still short of this. We have to find the maximum value, state the maximum value, and the period of the graph. So yours the maximum. Maximum is 2, and your period is 2 pi divided by 2, which is pi. Okay, part C, find the number of solution. You can see here that this equation here, we are short of a plus 1. See, yeah, state the number of solution. This is cos square. Look at it carefully. We tend to straight away say, oh, from the graph, we look at number of intersection, but you need to show this. Okay, let me write over here, because your equation is now sine 2x plus sine x equals to cos square x. Now no, this is cos square. So what I need to do is to change cos square to cos 2x. Yeah, we need to change to cos 2x, right? Okay, so if you look at your graph, okay, look at this one. Cos 2x, we know is 2 cos square x minus 1. So you bring this over, what we have, bring this over, we know 2 cos square x is now cos 2x plus 1. This is from the second formula for cos 2x, yeah, double angle formula for cos 2x. So this will be cos 2x plus 1. Now your left hand side here represent the first graph, right hand side represent the second graph, right? So your number of solution, this is C, is your number of intersection. So how many intersection here? Okay, I highlight using red pen. Okay, I can't use red, use blue, green. Okay, 1, 2, oh, only 2 solution, right? So number of solution is just 2. They only intersect at 2 points. Okay, you don't have to find the exact solution, just find the number of solution. All right, moving on, question number 12. Okay, prove this identity. Okay, so part A, left hand side. I would say this is quite a typical, quite a standard exam question. So if you have tangent, I would suggest you change to sine and cos. So it's sine square over cos square. This is sine square over cos square as well. Now I want to get rid of the fraction, so I multiply top and bottom with cos square. So this will be cos square x minus sine square x, right? So the more it times with cos, this becomes cos, and the second cos will cancel out, so I don't write. This will be cos square x plus sine square x. Okay, we know that cos square minus sine square is cos 2x. This is from the basic from the double angle formula, cos 2a. Cos 2a is cos square a minus sine square a. Yeah, please refer to the formula, you cannot remember. And the one below is cos square plus sine square. This is from the basic identity. Cos square plus sine square is 1. So you will get cos 2x, which is the same as your right hand side. Okay, so I'm going to sketch a graph over here. Okay, so second part, we are sketching the graph for cos 2x. Normally we draw 2 cycles for cos 2x, but here we're drawing up to 3 over 2 pi. So okay, if I were to draw a basic cos 2x, right, it's supposed to be up down like this. This is 2 pi, but we're not drawing up to 2 pi, we're drawing up to 3 over 2 pi. That means 1.5 cycle. So if you want to draw 1.5 cycle, whoops, okay, 1 and 2, so you need to divide into 6 parts. 1, 2, 3, 4, 5, maybe 6 up to here. All right, so let's put all the points 1, 2, 3, 4, 5, 6, 7. So this is x, so we go 1 minus 1, 0. This is down this way, up this way, down again, oops, down again. Wow, this is a bit ugly. Not perfect, but it's okay. Alright, so yeah, my graph, okay, I think the last part is a bit low because my point is a bit low. So I need to put it a bit higher. Yeah, 1.5 cycle. So it looks like this. Okay, now let's write down all the segment here. This is pi, half pi. Well, I can put a quarter pi here. This is 3 over 4 pi, 5 over 4 pi. Yep, and my graph is done. Okay, next, they say by using the same axis, draw a suitable straight line to find number solution to this equation. Now, immediately I can see I need to use the result from the first part. This is 5 pi, 1 minus tangent square x equals to x 1 plus tangent square x. Now just take note, look at this, 1 minus tangent, 1 plus tangent. So I'm going to bring this down, alright, and I'm going to bring the 5 pi over. So this is the same as my left hand side, which is the same as my right hand side. This is my left, my right is cos 2x, right, from here. So the suitable straight line we have to draw is y equals x over 5 pi, right? And for a straight line graph, after all, we just need 2 points. We put x equals 0, y equals 0. Now we can use any other point, but most of the time we just take the biggest and smallest, but largest is 3 over 2 pi. If you sub inside x, 1 over 5 times 3 over 2 is 3 over 10. This is 3 over 10. Very small value. So, okay, I'm going to use a blue color, 0, 0 here. Now, 3 over 10 will be around here. It's less than half. Very small. Just draw. Okay, my line is a bit off. Okay, I don't want to use a ruler because it takes a long time. No, I don't want to do this. I said iPad will auto correct it. Okay, so it looks like this. Can, yeah, can accept lah. Yeah, the iPad will auto change it to horizontal line. Don't want to do that. Okay, so now my number of solution is my number of intersection. How many intersection? 1, 2, 3. So just write down number of solution is just from the graph, 3 solution. Okay, this is a usual paper 2 question, right, in SPM. Okay, let's look at question 13 now. Okay, solve this equation. Here we got 3 equations to solve. Okay, so first one, okay, A, Roman 1. Okay, so for me, I'll just expand sine. Remember, you got to use the what do you call that? The addition formula: sine A cos B sine x cos 30 plus cos A cos x sine 30. The result is 2 cos x. Okay, now, and I hope you remember your special angle. Cos 30 is sec 3 over 2. Sine 30 is 1 over 2. This is 2 cos x. Okay, next I multiply everybody by 2. So I get sec 3 sine x, and this will be cos x. This will give us 4 cos x. Okay, just bring all the cos to the same side. I bring the cos over here. So I will have root 3 sine x equals to 3 cos x. Now we know sine divided by cos will give us tangent. I bring the cos down. So this will be tangent. 3 divided by sec 3 is still sec 3. So your tangent x is sec 3. You can use your calculator, find your reference angle. Reference angle is 60. Now, since x is between 0 and 180, now we know tangent is positive in quadrant. This is positive, 1 and 3. First answer is 60. Second answer is 180 plus 60, which gives us 240. Okay, now B I'll have to do below here, right? Okay, so you refer to your question again. For part B, right, my first equation, I'm given secant, 2 secant. So secant is 1 over cos. So just bring the cos down, right? This will be 5 secant as well, cos x plus 20. So, sorry, x minus 20. So I'm going to expand straight away. I just don't want to waste time. Cross multiply and expand. Now, cos x minus 20 is cos x cos 20 plus sine x sine 20. This will be 5 cos x cos 60 minus sine x sine 60. Now, I find it's a bit hard to keep writing so many things. So what I will do is I will change to decimal. I times in 1 by 1. I change to decimal, right? Like, what is cos 20? Time a calculator, then you times 2. Yeah, 2 times cos 60 on your calculator, it will give us 1 point. But please use more decimal point, 1.8794. I use 4 decimal places. This is cos x. 2 times sine 20 will give us 0.6840 sine x. 5 times cos 30 is just, cos 60 is just half. So it's 2.5 cos x. 5 times sine 60 is 4.3301 sine x. Okay, now we group all the sign on the same side. So I think I bring this sign here, bring this sign over to the right, bring the cos over to the left. So you will get 5.0141 sine x equals 0.6206 cos x. We know sine divided cos is tangent. 12377. I just use more decimal point here. Okay, then I use my reference angle. This is 7.06. I know textbook give more, but actually don't need so many decimal point for angle in degree, right? 2 decimal point is good enough. So my first answer 7.06, second answer is 180 plus, because this tangent again is positive. Tangent is positive in quadrant 1, quadrant 3. So this answer is just 187.06. Okay, lastly look at part C. Okay, part C, the whole expression here, you're given tangent x plus tangent 15, 1 minus tangent x, tangent 15 is 2. Now remember, this is actually in the form of tangent A plus B, where your A is x, your B is 15, so you put this together is tangent x plus 15, isn't it? Yeah. And from here, use your calculator, find your reference angle, tan inverse 2, you will get 63.43. Now we know this is positive 2. So tangent is positive, again, quadrant 1 and quadrant, don't need to write separately, I can just write here, quadrant 4. Okay, I'll just, I'm still undecided to write this. Okay, I'll just write this straight away. 180, quadrant 3, 63.43. Whatever you get, just minus 15. My first answer is 48.43. Second answer, 228.43. Alright, this is still very long. We still got a long way to go. This is just part A. Let's look at part B. Okay, part B. This time you have to solve involving radian. Okay, first one. You have 3 sine x, okay, cos x plus pi over 4. So this is 2, cos x, cos pi over 4, minus sine x, sine pi over 4. Okay, times inside. What is cos pi over 4? Cos pi over 4 is cos 45. So it's, you can write, if you type in your calculator, if you're not sure, it's 1 over sec 2 or sec 2 over 2, because calculator will rationalize the denominator for you. So I figure it's actually easier to use sec 2 over 2, so I can cancel with a 2, right, and get sec 2. But if you do the other way around, 1 over sec 2 also can, because 2 divided by sec 2 is still sec 2. So this one you minus times in 2 sine x, also the same, sec 2 over 2, cancel them, left with sec 2 cos x minus sec 2 sine x. Okay, now you need to bring this over to the left. So once you bring this over, you get 3 sine x plus sec 2 sine x equals sec 2 cos x. Put it together, right, you will get this. And we know sine divided by cos gives us tangent. Can you just write tangent? Just write tangent. Sine divided by cos is tangent. And this will be sec 2, 3 plus sec 2. Alright, now use your calculator. You can type this in. If you want, you can write this 3304, yeah, or more. Reference angle is 0.3100. Now I want the textbook give a slightly different answer, 3102. Yeah, I think 3100 is the more accurate one. If you use more decimal points, it's around there. Now, your first answer is 3100, and we know again tangent is positive. Quadrant 1, quadrant 3. Quadrant 3 is pi plus 0.3100. So this answer is 3.452. Okay, answers are all in radian. Okay, wow, this is very long. I don't know whether I have enough space for all. Okay, let's see. B, do I have enough space? Can I do B? If I don't have enough space, okay, I try to squeeze everything. And B over here, okay. Wait, this is B. All right. Now, you start off with 2 tangent x plus 3 tangent x minus pi over 4. Okay, I'm copying the question. Can I not copy the question straight away? I expand this. I don't want to copy the question. I just expand my tangent A minus B. So this will be tangent A minus tangent B over 1 plus tangent A tangent B. Yeah, the result equals 0. Now we know tangent pi over 4, tangent 45 is 1, so this will be tangent x. Okay, again, I have one trick to simplify your working. Can we let tangent be t? You see, for sine and cos, right, it's very hard for us to use substitution. Why? Because you have sine A and cos A, they are two different function, right? You have cos A sine A, you have cos x sine x, they're different function, and we normally will combine to be tangent. But when you use tangent, right, there's only one variable, there's tangent. So if you really want to simplify it, we can just let tangent x be t. So you don't have to write whole lot of things. This is t minus 1, 1 plus t. And since tangent 45 is 1, this is just t, right? This is 1. Okay, so next I multiply everybody by 1 plus t. So 2t 1 plus t, this is 3 with the t. Okay, I don't want to expand first, do a bit slower. T minus 1, right? Okay. Next, expand the bracket, 2t plus 2t squared. Okay, I wrote this wrongly. This is a plus. Oops. This is a plus. Okay, so this is plus 3t minus 3 equals 0. 2t squared plus 5t minus 3 is now 0. Okay, we can factorize 2t, t, 3, 1, plus and minus, plus 5 minus 1. Okay, t is now half, t is now negative 3. Remember, t is your tangent x. We're not done yet. So, remember this time we are finding angle in radian. So, shift tangent 1 over 2. Okay, can I not write reference angle? 0.4636. Okay, I'll just write. Second one, what's your reference angle? 1.249. So the first one, your tangent is positive, 4636, and quadrant 1 and quadrant 3. Second one is negative, so we take quadrant 2, 1.249. Quadrant 2 is here, and quadrant 4 is here, 2 pi minus. So your final answer, now here I arrange a little bit. This one I write first, 1.893. Next one is 3.605, 5.034. There you go, 4 answers. Okay, all right. Next one, okay. Okay, for the next question, yeah, the first time I look at it, it's like, whoa, it looks very hard. I don't have enough space. Oh, see, I don't have enough space. I need to erase this. So it's okay, just erase. Doesn't affect you all. Yeah, it's better to erase it so you can see clearly. All right. Okay, I'm going to show you part C here. All right. The first time I look at it, this question is very hard. Okay. It's not supposed to be here. Okay. So now you have tangent. This is part C. Okay, let me move this down a little bit so you can see. Can you see? This is tangent 5x equals tangent 2x. Yeah. The first time look at it, like, wow, this is very hard for form 5. Why would they torture student like this. Then think about it, 5 and 2, what is the relationship? Now we know 2 plus 3 is 5, so we can use 3x plus 2x, right? Okay, then we know that when you use addition formula for tangent, is tangent 3x plus tangent 2x divide 1 minus tangent 3x tangent 2x, right? You see that? Okay, look at this. Can we times the whole thing over? So when you times over this, tangent 3x plus tangent 2x equals tangent 2x minus 3, okay, wait, tangent 3x and the tangent square 2x. Now the good news is I can cancel these two, right? And I can bring this over to the left. So tangent 3x plus tangent 3x tangent square 2x is now 0. Take out tangent 3x. When you take out this tangent, see, this is your tangent here. Take out this, you're left with what? You're left with 1 plus tangent square 2x, right? So it's either tangent 3x is 0 or tangent square 2x is -1. But we know we cannot square something and get -1, right? We know that this is an impossible value. You can't, whatever value of tangent, you can't square it and get negative. It's always positive. Any number you square is always positive, be it positive or negative, right? So we ignore this. We know it cannot be -1, so we take the first answer. Now, as you know, tangent is 0. Where is tangent 0? Tangent 0, if you can use a graph at 0, pi, 2 pi, and so on. Now you go back to the original question. Question say, I mean, the domain given, x is between 0 to 2 pi. So 3x will be between 0 to 6 pi, right? Okay. Now, the first answer I can go is 0. Second answer I can go to is pi, right? Okay. The next one will be what? 2 pi, yeah. Or you can think this way. You can use unit circle. Tangent is your y over x. Y over x is 0 here, here, then here, here. You keep going on and on, right? 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, right? Okay. So with that, you divide 3. This is 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, 6 pi divided by 3 is 2 pi. There you go. That's all the answer. Okay. It's very long, right? Okay, the next question. Oh, we're still far from the finishing line. What is it? Okay, the gravitational acceleration is the acceleration due to gravitational attraction on the body to the center of the Earth. So the acceleration g depends on the latitude, theta of the place. Find the value g can be calculated using the following formula. Calculate the gravitational acceleration for Kuala Lumpur. Okay, this one is a bit, how would I say? I Googled latitude for Kuala Lumpur. Now, I don't know whether you all know about longitude, latitude, it's geography, right? Okay, this is our planet Earth. We are near equator, but we are not on equator. We are slightly, this is our, Malaysia is here, yeah? Right, we are slightly above. If you, this is your latitude. Latitude is the height. Okay, should I draw a view from here? View from the side. So the higher you go, this is your theta, this is your latitude, right? Okay, so your maximum you can go is North Pole, is which is 0. So we say, for example, if this is 30 degrees from your equator, this will be 30 degrees north. Yeah, this is your latitude. Longitude doesn't affect anything, it's the latitude that affects the gravitational acceleration. So come back to this. So I Google KL, Kuala Lumpur, I got 3.14, yeah, 13914, right? So for Kuala Lumpur, for KL, your theta is 3.1139, so it's 14. I just take 2 decimal. Yeah, that's what I got, right? So maybe Google, I don't think Google can give me a wrong answer. So I type in the calculator 9.7, the first part, 9.78039, 1 plus 0.005288 sine 3.14. Then you minus 0.00000, there are 5 0 with a 6 sine square, 2 times 3.1, 2 times 3.14. Can I write straight away? I write 6.28. You got to square it, huh? Okay, put another bracket. Okay, I got 9.7832. I don't know why the textbook gave 9.780. I don't know, maybe I said wrongly, or maybe they use a different point, right? So I assume it's not going to be the same, because this is already 9 point. Look at this. This is already 9.70. Yeah. So there's a small angle here, so it should be more than that, right? Okay. So anyhow, it's for you to double check. Okay. Next. Now this is a very interesting one. Determine the latitude when the gravitational acceleration is maximum stated value. Okay. I was trying to use at first. I was trying to do differentiate the trigonometric function, but you don't know how to differentiate trigo function yet, not your syllabus. All right, then I figure, hey, if you differentiate the trigo function, number one, you can't do it from phi. Number two, is also even quite complicated with the function that we'll get. So now you got to think, here your equation is g equals to 9.78 blah blah blah, open bracket 1 plus 0.0 blah blah blah. There is a sine, then you minus 0.00 blah 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 sine square 2 theta. So in order to maximize your g, you need to maximize your sine theta and minimize your sine 2 theta. Am I right? Because you're going to minus this, you're going to minus the sine square 2 theta. You're going to add your sine theta. So you want to maximize sine theta, minimize sine 2 square 2 theta. Now you go back to the concept latitude. I hope whatever briefly that I've explained to you earlier, your theta here, latitude, is measured from here, from over equator. The maximum you can go is only 90, right? So now, in order to get, we know sine 0, okay, for sine theta, right? Sine 0 is 0. Sine 90 is 1. Right? Correct. So your sine theta is maximum at 1. Correct? Your sine theta is maximum at 1. So we will say, okay, when your sine theta maximum is 1, what happened to your sine theta? Okay, what's your theta? Okay, maybe I should say sine theta is maximum 1. Theta will be what? 90, right? When theta is 90. So what happened to sine 2 theta? Sine 2 theta will be what? Sine 180. What is sine 180? 0. Wow, this is perfect. So this is going to give us the minimum value. Your sine 2 theta is going to be 0 when your sine theta is 1 at 90, right? So I can now sub in theta with 90. This is 9.78. Wow, this is very long. 239 1 plus 0.00528. Okay, 0.05288. Now I'm not going to write sine 90 because sine 90 is what, 1, right? So this is 1. Then minus the last part is going to be 0. Okay, don't believe me, 0.00006. Okay, I need to erase this. I don't have enough space. Yeah. So 0006, 0006, and this is now 0. Okay, and this will give us 9.832. Yeah, correct? Yeah, sine theta's maximum is 1. When sine 2 theta is 0, if you put 0 inside here, 1 inside here, you will get the maximum gravitational acceleration. Now that happened when theta is at 90, so that is at North Pole. Okay. All right. Next question 15. All right. So here we have to use a formula for area triangle diagram on the right show point P cos B sine B, point Q cos A sine A, yeah, located at the circumference of the unit circle. So okay, use two different area formula for area to show that sine A cos B is sine A minus B is the same as sine A cos B minus cos A sine B. Okay, maybe I start off with which one? I start with the first one, area half. Now, but when we do this, remember we got to choose, if possible, choose in the anti-clockwise, because anti-clockwise is positive. So we start with point origin 0, 0. Point P is cos B sine B. Point Q is cos A sine A. Then you repeat the first point. Okay, multiply downwards. This will be 0. Cos B sine A, cos B sine A. You minus this way up. This will be 0 and sine B cos A, the other way round. All right, now maybe I rewrite lah. It's quite ugly looking, right? Yeah. So yeah, it's quite ugly looking. Never mind. Normally write cos first lah. We write sine first. So this will be sine A cos B minus cos A sine B. So I write in this form. Now the second formula is half AB sine C. So we know we can use half AB sine C. Now AB will be your the length here, which is your radius, 1, 1, and sine. Now notice that A is all the way to here, B is up to here. So the angle between them, angle POQ, is basically A minus B, which is half sine A minus B. So this is your equation 1, this is your equation 2. We sub 2 in 1. We say half sine A minus B is now half sine A cos B minus cos A sine B. Cancel all the half. Sine A minus B is sine A cos B minus cos A sine B. Right, isn't this wonderful? Right? Alright, I managed to show the answer. Okay, let's move on to the last one, question 16, finally. So here we have 3 formula to prove. Alright, so now the first formula you have to start with part A. I'll write this as left hand side, 1 over tangent x plus cotangent x. Okay, so there are many ways to do this, but I'm thinking maybe I just change everything to sine and cos, right? So most people would prefer, or we're more familiar, that we change to sine and cos. Cotangent is cos over sine, tangent is sine over cos. So I multiply top and bottom with sine cos and sine cos. So this will be sine x cos x. Now what happened when I times with sine? Okay, the first one, right, you see I cancel the cos. Sine times sine, I cancel the cos, then I times with sine. I get, I get sine square. Okay, the second one, I'm going to cancel the sine. I take cos times cos, I'm left with cos square. Now we know sine square plus cos square is actually 1, right, from the basic identity. So over 1, therefore, this is just sine x cos x, which is the same as your right hand side. Okay, so which is this answer. Okay, all right, B. I start off with left hand side, my sine x. Now I'm not going to copy the question, I'm just going to write sine x minus cos x. Tangent we know is sine over cos, cotangent is cos over sine. So let's combine this, sine x minus cos x. This is, okay, cross over, sine times sine, sine square, cos times cos is cos square. My denominator is sine x cos x. Alright, now again, we know sine square plus cos square is always 1 from the basic identity. So we get sine x minus cos x over sine x cos x. But if you look at this, hey, none of this is the same. Yeah, they're not the same answer. So what would I do? Okay, we can split them. Now we know sine can leave. Okay, I do a bit slower so you can see. This is sine cos. This is cos. Oops, very ugly. Let me write nicer. When I write very fast, it tends to look a bit ugly. Sorry. So yeah, sine and sine can cancel. 1 over cos. Cos and cos can cancel. 1 over sine. And what is 1 over cos? 1 over cos is secant. 1 over sine is cosecant. And this is the same as my right hand side here. Secant x minus cosecant x. Alright, okay, last one. Okay, look at the question. I move this up. Yeah, I like a blank page without erasing them. So this is C, cotangent x minus tangent x divide cotangent x plus tangent x. Okay, I see I'm not going to copy the question and I just did. Okay, never mind. Left hand side, I change everything to sine and cos. Cotangent is cos over sine. Tangent is sine over cos. There's another one here. Cos over sine. Sine over cos. Now in the past I will tell the student combine to make the denominator the same, then I simplify. But over a period of time, I find, oh, this is a bit slow. Why don't we just multiply top and bottom with sine and cos, right? So when I cancel sine, look at the first line, cut, I times inside. I'm left with cos square, right? Okay, and the second one, I need to cut both, not the first one. Second, I cancel this, sine times sine, right? I'm left with sine square. So this is sine square. Now I do the same for my denominator. I cancel sine and sine, I get cos square. The second one, I cancel cos and cos, I get sine square. Now, this is now cos square minus sine square. I don't want to change to cos 2x because the answer doesn't have cos 2x. And cos square plus sine square, as we know, is just 1 from the basic identity. This is cos square minus sine square. And this is the same as your right hand side. You move this up, you can see is, whoa, this is the answer. Alright, yeah, we are done. I spent almost 2 hours recording this. Right, I hope you learned a lot from my explanation. Yeah, I hope you enjoyed this video. Right, hopefully it can help you to solve your problem. Yeah, your homework. Yeah, and yeah, just before we go, yeah, we got lots of books. All right, drill practice. I think I always say this in my video. We have what they call learning modules that comes with learning videos. Yeah, if you're interested, yeah, to find out more, stay in touch with us. Yeah, get in touch with us. All right, or you can order our book. Yeah, from Shopee. Past year question. We have past year question, topical practice, drill practice, and all that for further exercises. Thank you for watching this video. See you guys in the next video. Right.